चतुर्मुखसमारम्भां वाग्भटाचार्यमध्यमाम् अस्मदाचार्यपर्यन्तां वन्दे गुरुपरम्पराम्. Good morning to all the viewers. Respected speaker Dr. LAXMIKANTH sir, Event President Dr. Saida Akhtar Fatima Madam, Principal TGAMC, Event Organizer Dr. Rajshekar Gandhi sir, Professor and Lecturer, Department of Triviguna, Organizing Secretary Dr. Madhav Digag sir, Professor and Lecturer, Department of Ayurveda and Research Methodology and Biostatistics. Myself, Dr. Jaydevan A, first year PG scholar, Department of Rashyastra and Biostatistical, take this opportunity to welcome you all to the 7th live session of National Level Webinar Series, E-ANUSANDHANA, organized by Department of Research Methodology and Biostatistics, TARANATH Government Ayurveda Medical College and Hospital, Ballari. As I am one among us, your student, it gives me immense pleasure to welcome you to the session, sir. We all are very grateful and most delighted to have with us today an eminent speaker, Dr. LAXMIKANTH sir, who will be sharing his exceptional view on the topic T-test and chi-sqaure. I hereby invite my colleague, Dr. Surega, to introduce you, sir. Thank you.
Good morning, all the viewers. Myself, Dr. Sureka, first year PG scholar, Department of Panchkarma. It gives me an immense pleasure to introduce today's guest speaker and my guru, Dr. LAXMIKANTH sir. Sir has completed BMS from RGHS Bangalore and MS from RGHS Bangalore, and sir has completed PhD from Jamnagar University. And sir is currently working as a professor in the Department of Shalyatantra and HOD in research and medical statistics. Sir has presented 5 papers in international and national seminars, and sir was chairperson for 6 international seminars, and sir has presented 8 scientific articles in international journals and even PubMed. Today, sir will be dealing with the topic T-test and chi-sqaure test. With this brief introduction, I welcome you for the session, sir. Session is over to you, sir. Thank you.
Thank you. Hello, good morning to all. Hello. Very good morning to all. So today I am going to deal with some tests, statistical tests, what we are using in our research studies, especially T-test and chi-sqaure test. So I am going to share my screen. Once again, very good morning to all. Thank you for inviting me as a resource person. So directly coming to the topic, that is first I will explain about a T-test. Later, that is, we will know about chi-sqaure test. There is to find the significance of a difference between means of small samples. So usually we use T-test, but the condition is the data, the character must be quantitative. Here we should know what are the variable and what is the type of data. Usually we have 2 variables in our study. One is character, another one is frequency. In that character may be of qualitative or it may be of quantitative. What is qualitative and what is quantitative, that should be very clear. The character which can be measured, which can be written in numbers or which can be expressed in numbers, numericals, it is termed as quantitative data. Whereas the character which cannot be expressed in numbers or written in or not measurable data, it is qualitative data. So What is this frequency? Means number of observations included in our study, it is frequency. So for quantitative data, where the data is measurable, the character is measurable, so the parameter is measurable or expressed in numbers. For such data, if the sample size is 30 or less than 30 according to text, so we used to apply T-test. If the sample size is more than 30, we used to apply Z-test actually. So for small samples, their Z values do not follow the normal distribution. That is why another test is used which follows the distribution termed as T distribution. It was designed by W.S. Gossett. Because of the name of his pen is a student, so he named that test name as student's T-test, which says the ratio of observed difference between two means to the standard error of difference. So this ratio follows T distribution and it is denoted by letter T. This T corresponds to Z in large samples. As earlier I told, for small samples, that is a sample size 30 or less than 30, we are applying T-test. If the sample size is large, we used to apply Z-test, where the probability P of occurrence of any calculated value of T, it is determined by comparing with the value given in the row of the table. What does it mean? That is, there is a T distribution table. See, this is the T distribution table in which you can say first is degrees of freedom, next is 0.10, 0.05, 0.02, 0.01, 0.001. When the calculated or obtained value comes, that is falls in these areas or these values, these are the rows. So if it exceeds, if calculated t value exceeds this numbers, then it is said to be, or else it is determined by comparing it with the value given in the row of the table, which corresponding to the degrees of freedom derived from the number of observations. Say first column it is degrees of freedom. In this row, so we will go through this. In this column, we will go through this rows. What is the degree of freedom? If, for example, if degree of freedom is 18, so we will search the obtained value in the 18th row where it falls. If it falls here, that is it is 0.001, then we will say it is a significant, highly significant or significant at this level. So the table gives the highest obtained values. This table, it gives highest obtained values and these values will not change. These are fixed of t under different probabilities p in decimal fractions like 0.10, 0.05, 0.01 and 0.001 with corresponding to the degrees of freedom. Then probability when it is converted into percentage, when these probabilities 0.10, 0.05, etc., these are converted into percentage, it is stated as level of significance. Like when p is equal to 0.05, it is stated as significant at 5% level. That means it is equivalent to 95% confidence limits in the Z test. So, if calculated value t exceeds this value, which is given under 0.05, that is a probability p is equal to 0.05, it is said to be significant at 5% level. So, according to our null hypothesis or a research question, the null hypothesis is rejected when the result comes significant, when the result, that is it exceeds the given value, then the obtained value exceeds the given value, then we dare to say that the null hypothesis is rejected and some alternate hypothesis is accepted, which is denoted as H1 usually. Then what is degrees of freedom here? So the quantity in the denominator which is less than 1, the independent number of observations in the sample. That is, for a single group, the degrees of freedom will be 1 minus number of observations or 1 less than number of observations, and the degrees of freedom for two samples or two groups, the degrees of freedom will be 2 less than total number of observations. It is written as, for two groups, degrees of freedom is equal to, here add circled, that is degrees of freedom for two groups, that is n1 plus n2 minus 2. n1 means number of observations present in the first group, n2 means number of observations present in the second group minus 2. That is, it is for two groups, and for single group, so n minus 1 degrees of freedom will be n minus 1. N is number of observations present in the group minus 1. So how to apply the t-test? Usually there are two tests, unpaired t-test and paired t-test. For single group, we are using paired t-test. For comparison between the groups, it is the test applied is unpaired t-test. That means within the group, if we want to know the significance, we are using paired t-test. In between the two groups, if we want to know the significance, we are applying unpaired t-test. So it is applied to find the significance of difference between two means, as for two groups unpaired, for single group it is paired, or else in between the groups unpaired, within the group paired. So some criteria are there to apply the t-test. First criteria is the sample should be randomizedly selected. Second, it is very important, for as it is a parametric test, the data must be quantitative. As I told, what is quantitative? That is, when character is expressed in numbers, character is measurable. What is this character actually? Like, it may be blood pressure, it may be hemoglobin, it may be RBS, it may be death, it may be survival, it may be disease, anything. It is a character. But when we come to know, like blood pressure, it is a measurable. We can measure the blood pressure, we can measure the HB, we can count RBC, but we cannot measure the death, we cannot measure the survival, we cannot measure the diseased one. When such characters are measurable, when the characters are measurable, these measurable characters are termed as quantitative. And when the characters are not measurable, these are termed as qualitative. So here the data must be quantitative, and the variable should be normally distributed for applying t-test. Then sample size should be less than 30 or less than 30, where in Z test the fourth criteria will changes, because to apply Z test the sample size must be more than 30. So coming to first test, that is unpaired t-test, which is applied to unpaired data. That means in between the groups, if you want to compare, we are using unpaired t-test. So unpaired data of independent observations. Two different observations are there, two different data are there. So two separate or different groups are present from two populations, which are drawn from populations. So as per the hypothesis, especially that is a null hypothesis, usually what we say is there is no real difference between means of two samples. That means there is no difference between two groups. So assuming this H naught, we will start our research work. By the end of the work, so when there is no difference in the calculated value and obtained value and that table value, then we will tell that H0 is accepted because our hypothesis is like that only. That is, there is no real difference between means of two samples. But after completion of the study, when the when the obtained values differ from the present table values, so then we have to reject the null hypothesis. So we have to accept some alternate hypothesis. Then so this is the formula for calculation of unpaired t-test. That is t is equal to x1 bar minus x2 bar divided by SE. What is x1 bar here? Here it is a mean of first group, that is x1 bar, minus x2 bar is mean of the second group. So divided by standard error of difference between these two groups. So that is why it is told that it is a ratio. See where it is like it is a ratio of observed difference between two means. That is, this observed difference is x1 bar minus x2 bar to the, that is standard error of difference. So the formula it is t is equal to x1 bar minus x2 bar divided by standard error. So here we have to calculate the mean of first group, mean of second group, and standard error of both the groups for unpaired t-test of unpaired data. So how to calculate this standard error is, it is another formula, that is formula for calculation of standard error is sigma, or it is also termed as a standard deviation, square root of 1 by n1 plus 1 by n2. So standard error is calculated, see, standard deviation into square root of 1 by n1 means number of observations present in the first group, plus 1 by n2 is a number of observations present in the second group. So for Z test, the standard error calculation formula differs. Here it is, we will know about only this much. So degrees of freedom, as I told, n1 plus n2 minus 2. So for calculation of this standard error, we have to calculate again this standard deviation. To calculate the standard deviation of two samples, it is termed as a combined standard deviation, like summation, that is a summation of square of difference between mean with individual observations of group 1 plus again summation of square of difference between mean with individual observations of second group. When we add these squared values divided by total number of observations minus 2, that is n1 plus n2 minus 2, then we will get this standard deviation value. When we square it, that is, we will get this standard deviation value. So t is equal to, so as you know now, x1 bar minus x2 bar divided by standard error. When we compare our calculated t value with the given table value at particular degrees of freedom, so we come to know that our value is less than the present value in the table, or it is more than the given value in the table. So if it is less than given value, then it is not significant. When it is more than given value, it is said to be significant at that level. When it is significant, then as I told, null hypothesis should be rejected. When it is less than given value, when the obtained t value is less than given table value, then the null hypothesis is accepted. It is not significant. It is said to be not significant. So these are the table values. So for t, it is termed as a t distribution or value of t, or probability of larger value of t actually. So second test is a paired t-test, where it is applied to paired data of dependent observation of from, that is, one sample. That means here only one sample is there. So we are having two data of a single sample. Two data means that is it is a paired data actually. What is this paired data of a single sample means? Usually in our thesis works, after dissertation works, so we select some drugs and we fix some parameters and inclusion and exclusion criteria after diagnosing. Then some assessment criteria are there. In those assessment criteria, we will fix that. Sorry, hello. Sorry, मैं थोड़ा busy हूँ, तो बाद में करता हूँ. So sorry. When that is we fix some data, when we fix some parameters to assess, so we will collect the data before treatment what we fixed. After collecting the before data of each individual observation, then we will prescribe some medicines, some that trial drugs. After giving administration of trial drugs, we will get the same data after treatment. So before treatment and after treatment, the data is collected. Such type of data is termed as a paired data. To compare between what is the difference between before treatment and after treatment, to know the level of significance or to know it is significant or not significant. So we used to that is apply paired test, paired T-test. That is, it is to know the significance within the groups. When each individual given a pair of observations, as I told, such situations usually we face in our medical research works. For example, to study the role of a factor when the observations are made before and after its play. So these are like what is the role of exertion on pulse rate? That means before exertion, what is the pulse rate? After exertion, then again you have to measure the pulse rate, count the pulse rate. Like, is there really the pulse rate is differing on exertion or increasing on exertion or not? To know this, so we are using paired T-test. Like that, means on leukocyte counts, effect of drug on blood pressures. That means before giving any medicines, what is the blood pressure? After administration of some particular drug, blood pressure is reducing. There is a role of that medicine to reduce the blood pressure or not. To know these things, so for a single group paired data, so we are applying paired T-test in our that is science like Google and Ayurvedic drug like or Bengal gram, garlic, etc. So, is these medicines are having or any effect in reducing the cholesterol level? To check in these things, so we are using paired T-test. So, to compare the effect of two drugs also given to same individual. So, for such data also, it is also termed as a paired data. So, paired T-test can be used. For example, like adrenaline and noradrenaline, so has any role on pulse rate? Either it reduces or controls or increases anything. So according to our research question, so we are using the paired T-test. So other like number of examples are there. So directly we will come to the formula for calculation of a paired T-test, where T is equal to x bar minus standard error. Actually it is, this is a standard error, this is x bar. Here only a single group is there, so before and after treatment data is there. So we have to measure the mean of that data first, that is only one group, divided by standard error. That standard error is calculated by this s divided by square root of n. What is this s? It is the standard deviation of that group. So how to calculate this standard deviation is, so it is a square of that is a summation of square of difference between mean with individual observations divided by n minus 1. See, for standard deviation also, for single group the denominator is n minus 1. For two that is groups, it is n1 plus n2 minus 2. So this is the formula for to calculate the paired T-test. Again I repeat, T is equal to x bar divided by standard deviation, this is actually standard error. First you have to calculate the mean of that group, then to calculate a standard error, so the formula is standard deviation divided by root n. How to calculate the standard deviation? Standard deviation is equal to square root of summation of x minus x bar whole square divided by n minus 1. So up to I explained theory part. Now little like examples I am going to explain. So first one like is the systolic blood pressure. Okay, is there any role of this drug or injection of drug? It is having any role to reduce or increase in this systolic blood pressure? Usually, I selected 9 normal individuals. That means having normal blood pressure, systolic blood pressure. So, who had been recommended for that is 5 minutes. That was 5 minutes rest was given to 9 individuals. Then, after that, that is a 2 ml of some hypotensive drug is injected, non-hypotensive drug. Then again, BP was recorded. So, say this is the table. It shows these are 9 patients. First patient is having, so before treatment or before giving injection, the systolic blood pressure was 122. After giving, it is 120, like that. If that is, you see the sixth person, before it is 130, after also 130. But you see somewhere here, like before in the fourth person, the before it is 115, after it is 110. Now how to calculate the t-test? This is that means I am having the data of single group, paired data actually. It is a before and after. Such type of data, it is termed as a paired data. So I have to apply paired t-test for such data. See, what I have to do is I should get the difference. How much BP is reduced in each patient, each person. I have to get it. Like in first person, 2 of Hg is that systolic blood pressure is reduced, like that. So in 6% there is no difference. In 7% you say 4 that is of Hg BP is reduced. This is either you take it as a before injection and after injection. Usually in our study we do before treatment minus after treatment. That is the difference between what actually we got. That is, it is written as X. So we have to calculate the mean of this data, this difference. For example, when we calculate, that is when we add these all, that is of the difference data, so we will get it is 27. When summation of, it is termed as summation of x. So summation of x, so x bar, the formula of that is to calculate mean is x bar is equal to summation of x divided by n. So here we got this summation of x. Summation of x is 27 divided by n is equal to number of observations. How many number of observations are here? That is 9. That means 27 by 9 will give you the mean of this data. So x bar is equal to summation of x. Sorry, here it is missed this one. It is summation of x divided by n. So is equal to 27. It is the summation of x. Say it is 27 divided by n is equal to number of observations. These are the 9 number of individuals are there. So 27 divided by 9 is equal to 3. So we got the x bar. X bar means mean. Mean of this series it is 3. Now what we have to do is we have to minus, that is subtract the mean in each these observations. That is 2 minus mean, 3 minus x bar, 5 minus x bar, 5 minus x bar, and this value is squared, like that. Say x minus x bar whole square, like that. In first observation you say it is 2. So 2 minus 3, mean is 3, square plus. So 3 minus 3, second, that is second, it is the difference is 3. So in such way, all that is individual observations, that is mean is subtracted in all individual observations, and we should get the squared value of those subtracted values, and we have to add all the that is squared values. So then we will get summation of x minus x bar whole square. So this is helpful or useful in calculating the standard deviation of this series. Already we have mean, we have to calculate the standard error for paired t-test. To calculate standard error, we have to calculate standard deviation. To calculate standard deviation, we should have this summation of this difference, that is summation of x minus x bar. These are the x values, x1, x2, x3, x4, x5, like that, x9. So minus x bar is 3, that is mean is 3. We have to, that is subtract mean in each observations, and that is squared. So add all those, that is summation means add all those squared values. So we will get 24. So in a standard, to calculate standard deviation, that is the square root of summation of x minus x bar whole square is equal to 24. So we will keep 24 here, divided by n minus 1. N minus 1 means number of observations minus 1. Here number of observations, you see it is 9. So 9 minus 1, it is 8. So square root of 24 divided by 8 is equal to, that is square root of 3. When we get the square root of value, that is standard deviation is equal to 1.73. That means this 1.73, it is utilized to calculate the standard error. We are having mean value, so we have to calculate standard error. Then x bar divided by standard error, we will get t value. To calculate standard error of difference, that is standard deviation divided by square root. This is the formula. Standard deviation we calculated as 1.73. 1.73 divided by square root of n. N is number of observations, that is 9. So we will get this value, that is 0.58. That means standard error is equal to 0.58 and mean is 3. Already we calculated this mean. So this 3 divided by this standard error is 0.58. So we will get a t value. So t degree of freedom is equal to x bar divided by standard error. X bar is 3, standard error is 0.58. We will obtain the value, that is 5.17. Why in degrees of freedom I wrote 8 is the degrees of freedom for single group, that is within the group, is n minus 1, as I told. So n is number of observations, that is 9 individuals, minus 1, that is 8. So at 8 degrees of freedom, the t value, obtained t value is 5.17. Now this value is checked in this table. See, this is t table, that is the probability of larger value of t. Our degrees of freedom is 8 here. See, the degrees of freedom is 8. So we should search in this 8th row, this degrees of freedom. See, in first column it is 1.86, 2.34 something, 2.90. So, but our obtained value, you see, it is 5.17. That means in the 8th row, the obtained value, that is, it is higher than this last given value, that is 5.04. So this means the obtained value is higher than this table value. So it is said to be highly significant at this level. This level in the sense it is 0.001. So what does it mean? This means the drug is really acting, or the drug is really reducing the systolic blood pressure. So our research, our question is like that only. Na? Did the injection of drug lower the blood pressure, okay, na, or not, like that? So when our t value, when calculated t value comes higher than the given t value, then it is said to be highly significant at the level 0. That is p value. It is 0.001. It is highly significant. That means there is highly difference noted by noted in this blood pressure by giving this or injecting this drug. That means there is a significant difference is there. So this is about calculation of paired t-test. Now we will move on to calculate the unpaired t-test. The formula, as I told, it is t is equal to x1 bar minus x2 bar divided by standard error. What is x1 bar? Here it is mean of first sample, and mean of second sample, it is x2 bar, and this is standard error. How to calculate the standard error for two groups? So this is standard error is equal to standard deviation into square root of 1 by n1 plus 1 by n2. And the degrees of freedom for two data, two samples is n1 plus n2 minus 2. Now we will calculate, that is by an example, like in a nutritional study. That means first get this that is like research work, like in 13 children's usual diet is given, along with vitamin A and vitamin D tablets are given to note or to check, is there any role of vitamins to increase the weight in these 13 children. This is first group. And in the second group, the number of children are only 12. So number, it is not compulsory that in both the groups the equal number of patients should be there. So that may differ. And in the second group, that is only 12 number of, that is, children are there, where only usual, that is, diet is given for those 12 children. The vitamin A and vitamin D tablets are not prescribed for this second group. That means like crossover study, like so for one group only the normal diet is given, for another group along with the normal diet vitamins are added. So then before, that is for a duration of like 12 months, 12 months in the sense like 1 year. So to know really these vitamins are having any role to increase the weight or not, to gain the weight or not. So to compare this one, so we are using unpaired T-test. If the sample size is less than 30 and if the character is quantitative, here weight, it is a character. So weight can be measured, weight is expressed in numbers, so it is a quantitative data. That means we can apply the unpaired T-test. So the question goes like this: can we say that vitamins A and D were responsible for this difference in weight? So now we will calculate. Now we will start our study. Like so, these are two groups. Say so this is actually first group. So number of, that is, children are 13. So here this is first group, and in the second group, say so only 12 children are there. So for first group, the children were given usual diet plus vitamins, that is vitamin A and D for 13 children, and for 12 children only, that is usual diet is given, vitamin A and vitamin D are not prescribed. Now what you have to do is, actually these values are uh, before treatment and after treatment. The difference between before treatment and after treatment obtained values are there, no? So these are those values. That means 5 pounds, 3 pounds, 4 pounds in third and 3 pounds in fourth children. These are gain in, that is the weight in first group. These are the gain in the weight in pounds in the second group. So with vitamins, this is the weight gain. Without vitamins, this is the weight gain for a period of 12 months. Now, when we calculate the mean of group A, so if we calculate the mean of these things, so the mean comes like 4. And if we calculate the mean of group B, if you calculate the mean of this, that is second group, so we will get mean is equal to 2.5. How to calculate? You know, that is x bar is equal to summation of all these values, that is summation of x. Summation of x means x1, x2, x3, x4, like that. So all these values are added, divided by 13. So for first group, and for second group, so summation of all these divided by only 12, not 13, because here only 12 children are there. So for second group, so x bar is equal to x1 plus x2 plus x3 plus up to x12. For first group, x bar is equal to x1 plus x2 plus x3 up to, that is, x13 divided by n. So here it is n is 13 in first group, here n is 12. So we got mean of group A and group A. Then we have to calculate the difference, that is squared value of difference between mean with observations. So earlier we calculated in same, that is in such, that is in that way it is calculated, that is summation of x minus x bar whole square of group 1 and summation of x minus x bar whole square of group 2. For group 1 it is 32 when I calculated. For group 2 it is 11. Then we got the x1 bar and x2 bar values. So T formula that is for unpaired T-test is T is equal to x1 bar minus x2 bar divided by standard error, that is we got x1 bar that is 4 minus x2 bar 2.5. We have to calculate the standard error. To calculate standard error, we have to calculate the standard deviation. So for two groups, the formula for standard deviation is equal to, that is the summation of x minus x bar, that is difference between mean with individual observation. These values are squared and added for group 1 and for group 2. So these both the values are added. That means first we have to calculate these things. So when we add these things, divided by n1 plus n2 minus 2. So we will get the standard deviation value. We can keep this in standard error formula. Say, so variance is equal to, so this is actually variance. So if you square it, when we square root, that is we get the square root value of this formula. So we will get standard deviation. So for example, like in this example, so what is this summation of x minus summation of, that is x minus x bar whole square for group 1 is we calculated as 32. This is 32 plus for second group it is 11. So 32 plus 11 divided by n1 plus n2. n1 is 13 children. In second group 12 children minus 2. So we will get 23. So if you add these two, that is we will get 43. If you divide it, so we will get the variance, that is 1.87. If you square root this 1.87, that is if you square root this variance, you will get the standard deviation value. So standard deviation is equal to square root of 1 minus 87. So the standard deviation we got is 1.37. This 1.37 is utilized to calculate standard error. So to calculate standard error, standard deviation into square root of 1 by n1 plus 1 by n2 for ungrouped, that is unpaired data or unpaired T-test. So SD standard deviation we know, that is 1.37 into square root of 1 by n1, that is 13 plus 1 by n2 12. So we will get this value, that is 0.16. When we calculate these two, so we will get standard error value, that is 0.548. See, our mean of first group is 32. Mean of first group is 4. Mean of second group is 2.5, and standard error is 0.548. So T is equal to, this is the degrees of freedom. So I will tell what is how to calculate this degrees of freedom. So mean of first group minus mean of second group divided by standard error. Mean of first group is 4 minus mean of second group is 2.5. As I told, this is mean of first group, this is mean of second group. 4 minus 2.5. See, 4 minus 2.5 divided by standard error. Standard error is equal to, see, this is standard error. See, this is standard error 0.548. So when we calculate these values, we will get the T value as 2.74. So we got T at degrees of freedom 2.74. What is, how to calculate degrees of freedom in two groups? That is, it is termed as the pooled degrees of freedom. So n1 plus n2 minus 2. n1 is 13, n2 is 12 minus 2. That is, we will get 23. That means in the given value, this is the T table. So at degrees of freedom, that is 23. Here is a 23. In this row, we should search for our T value. What is our T value? It is 2.74. See, 24, that is a 2.74 means it is higher than this 0.05 level. So 24, that is in this 24 degrees of freedom, when we check the obtained value in the given value, so our value is little higher than this given value. This shows the result is significant at 0.05 level. 0.05 level means, see our research question. So can we say that vitamin A and D were responsible for this difference in weight. If the obtained T value is less than given value, then the H naught, okay, na, it is accepted. But the obtained T value is higher than the given value, then we can say yes, vitamin A and D both are having a responsible factor to increase the weight. So H naught is rejected and H1 is accepted. So this is the calculation of paired and unpaired T tests. Now we will come to the chi-square test, where it is used to calculate, that is calculate the qualitative data. See, this chi-square test is not based on any assumptions. That means these does not follow normal distributions. So it follows some other distribution called as a chi-square distribution, where data are in frequencies. So first only I told that two variables are two. One is character, another one is frequency. Character, that is, it is a qualitative, quantitative. Qualitative, which cannot be measurable, which is not expressed in numbers. Quantitative, which is measurable, which can be expressed in numbers. So in some, that is studies, the character cannot be measurable, cannot be expressed in numbers, but can be graded. Gradings can be given. So for such data, so only data, that is frequencies are there. For such data, so we are applying the chi-square test. This test involves the calculation of quantity in the sense that frequency, not the character. So it is called as chi-square, written as this like a chi, okay, square, which is derived from, that is Greek. So it is pronounced as K actually, K-Y-E, K square or chi-square. So it was developed by, that is, Carl Pearson. So some applications are there for chi-square test. That is a test of proportion, test of association, and goodness of fit. So what is a test of proportion? That is, as an alternate test to find the significance of difference in two or more than two proportions. So in case of large binomial samples of a size more than 30, so test of proportions is applied. The significance could be found by calculating standard error of difference between two proportions. So chi-square, it is applied to find the significance in the same type of data. So with two more advantages, which are to compare the values of two binomial samples. I will tell what is these two binomial samples, even if they are small or less than, that is 30. For example, incidence of diabetes in 20 obese, non-obese patients with that of 20 obese persons. So that means in obesity, like diabetes, it is seen, that is two different groups are there, obese patients and non-obese patients. So in both the groups, so who are, that is suffering from diabetes, more suffering from, that is diabetes, to know this incidence of diabetes, so chi-square test is used. The test can be still applied provided correction factors, for example, like AIDS correction is applied when the expected value is not less than 5 in any cell. So I will explain in coming slides what is this expected value of the cell. When this expected value is less than 5, so we are using or applying this AIDS correction. So to compare the frequencies of two multinomial samples also, the same, that is chi-square test can be used. Now what is the test of association? To know that is the two, that is groups are, or two events are associated with each other or not. So how to test this association? So like there is any association between smoking and cancer, that is a cause and effect, treatment and cure of disease. Like is there any association? To know the association, so chi-square test is used. Vaccination and immunity, nutrition and intelligence, number of, that is examples are there. Then there are two possibilities: either they influence each other or they do not. That means smoking can cause cancer or smoking cannot cause cancer. So we have to, that is collect the data of cancer patients who are smokers, and we have to collect the data of cancer patients who are non-smokers. Then we have to test the association between this cause, smoking and smokers and non-smokers, like that. So chi-sqaure has an added advantage, like it can be applied to find association between two discrete attributes actually when there are more than two groups, as happens in that is multinomial samples. For example, to test the association between number of cigarettes equal to, that is 10 or more than 10, or in between 11 to, that is 20, 20 to 30. So how many number of cigarette smoking per day for this period will cause cancer? To know these things, so we can apply this chi-sqaure test. So, or else another example, that is the between, that is incidence of filariasis and social classes. Social class, that is group 1, group 2, group 3, group 4, or else very rich, middle, or poor. So is there, that is any role of this social class to cause this filariasis? So for such, that is data, we are applying a chi-sqaure test. So to calculate, like a table should be prepared to calculate this chi-sqaure test by enumeration of this qualitative data. See, this is very simple table, like these are the groups, two groups, control group and a trial group. So it is a table of like vaccination, I think, like after giving vaccination, or that is after giving any drug, how many number of patients were died and how many are survived, and by giving placebo, how many are died and how many are survived. So you can take example of COVID-19. So usually we are using like SCQ or any retroviral drugs, or like azithromycin, some other antibiotics. So actually these drugs are having any role to control this disease or not? How many died? How many survived in COVID-19 patients? To check these things, say in control group, that is on in placebo group, first group is given placebo, so which is taken as a control group. So total number of patient in first group is 35. Among 35, 10 are died, 25 are survived. Whereas in the second group, that is a trial group, it is on a drug, like HCQ is given to control the COVID-19. So number of patients in the second group is 65, and among 65, 5 were died and 60 were survived. So to check the association and other things, significance, so we are applying a chi-sqaure test. So for chi-sqaure test, we have to prepare such a table. It is termed as a 2 into 2, that is contingency table. Say died, survived. So for group 1, that is for group 2, how many died, and for group 1 and group 2, how many survived. So totally how many died, that is 15. How many survived, it is 85. The total number of samples, it is 100. That means total 100 number of patients are included in the study, which are divided into, that is two groups. In one group 35 patients are there, in second group 65 patients are there. So in first group, that is 10 were died, in second group 5 were died, and in first group 25 were survived, in second group 60 were survived. Then how to calculate this? So such type of data, it is termed as binomial data. So example for multinomial data, see here. So there are, that is like filariasis, I told now. So is there having any role of this social class to cause this filariasis? See, first group, class 1, class 2, class 3, class 4, these are the positive cases and these are the negative cases. So total number of, that is cases that is for the study. So you have to add these things. Then we will get the total number, that is total, it is 1500 filarial patients are collected. This data is collected. So it is distributed, that is according to their social class, and how many are positive, how many are negative, it is calculated. So for such table also we can use a chi-sqaure test. What is a test of goodness of fit? That is last, that is test in chi-sqaure test, that to determine if actual numbers are similar to expected or that is theoretical numbers. So which is known by this goodness of a fit to a theory. That is, it is written as or denoted as k. K is the number of classes for chi-square in the goodness of a fit test. We can find whether the observed frequency distribution that is fits in a hypothetical value or hypothetical data or not. So this test of goodness of fit is used. It is based on that is assumption of no difference between observed and hypothetical distribution. That is, it is a null hypothesis. So always that is we go by this statement or this null hypothesis that there is no difference between the observed and hypothetical. Hypothetical means the table value, hypothetical distribution. The highest values of chi-square obtained or obtainable by chance are worked out by given that is worked out with seeing this Fisher table, that is that probability chi-square table at a different degrees of freedom. So at under different probabilities such as 0.05, 0.01, etc. If calculated chi-square value of our sample is found to be higher than the expected value in the table at a critical level of significance, that is probability of 0.05. So our obtained value is higher than the table value, then hypothesis of no difference between two proportions is rejected. Simply H naught is rejected. Null hypothesis is rejected. If the obtained value is lesser than the given value, then null hypothesis is accepted. So if calculated value, that is I told how to apply the where to apply the AIDS correction in chi-square test. That is hypothesis of no difference is sorry what it is sorry 1 minute. Coming to direct data calculation of a chi-square test. Here also the sample should be selected randomized, and the character must be qualitative, wherein t-test character must be quantitative. Here, if the lowest expected frequency actually should not be less than 5. If it is less than 5, then AIDS correction can be applied. So to apply the AIDS correction, see the formula for calculation of chi-square is chi-square at degrees, particular degrees of freedom is equal to summation of, so this is O minus E. O is observed value, E is expected value, that is a square of difference between observed and expected value of each cell minus divided by expected value. So the formula for chi-square is summation of difference between observed and expected value divided by E. So of each cell actually. So say here O is observed value, E is expected value. This degrees of freedom will be, to calculate the degrees of freedom in chi-square test is the formula that is it is C minus 1 into R minus 1. What is C, what is R here is C is column, number of columns, R is number of rows. I will explain what is this C and R, how to calculate. And already we are having obtained values. So when you collect the data, we obtain the data. This is O, but we have to calculate expected value. To calculate expected value, the formula is E is equal to column total into row total divided by sample total. So this you should keep it in mind, this expected value E. So some restrictions are there to calculate the chi-square test. If expected value of any cell is less than 5, then it will not be that is reliable to that is it is not a like accurate result or reliable result with 1 degrees of freedom. But anyhow, in such conditions, AIDS correction can be applied. So in tables larger than 2 into 2, AIDS correction cannot be applied. That is in multinomial tables, AIDS correction is not applied. So these are the restrictions. In binomial tables, 2 into 2 contingency tables, that is AIDS correction is applied. So it tells the presence or absence of any association between two events only, but it does not, that is measure the strength of association. So these are the restrictions of chi-square test. See, with AIDS correction, the formula is chi-square, that is degrees of freedom 1 at 1 is equal to summation of, this is modulus. Modulus in the sense we are ignoring this negative sign. If the value of the calculated value is minus O minus E, observed value minus expected value, minus, that is half whole square divided by expected value. So if the expected value of any cell, if it is less than 5, then chi-square is calculated with this formula, with applying this AIDS correction. Otherwise, the formula is same. So then, calculation of chi-square, how to calculate with example. See the table, what I explained here earlier is a table prepared by enumeration of qualitative data. That means there are two groups, group 1 and group 2. Group 1 is control group, group 2 is trial group, where on placebo 10 died and 25 survived, total are 35. That means, see, this is row, this is row total for group 1, row total for group 2, this is column total for group 1 and column total for group 2. Total number of died patients in our study, it is 15 out of 100. This is a total sample. So total number of survived patients, that is in the total sample, it is 85. So in first group, that is 35 patients are there. In second group, 65 patients are there. Total number of patients are 100. See, this is row total 1, row total 2, column total 1, column total 2. This is sample total. Is it clear now? Then, see, here what we observed, this is observed data. This is observed data. These are the E cells, first cell, second cell, third cell, and fourth cell. So observed data 1, 10, observed data O2, 25, O3, 5, O3, O4, 60. That means we have to calculate, see, O1 is there, we have to calculate E1, E2, E3, and E4. Expected value 1 for this cell, and each cell, that is for these 4 cells, we have to calculate the expected value. See, these are the observed values. So what we observed is, in first group 10 died, 25 survived. In second group 5 died, 60 survived. So O1 is equal to 10, O2 25, O3 5, O4 60. Total, it is sample total, actually it is 100. Total 100 patients are there. So how to calculate this expected value? See, expected value formula, euro, that is I told, E is equal to column total and row total divided by 100. Say for this cell, for O1, the row total is 35 and column total is 15. That means 15 into 35 divided by sample total 100. Say 15 into 35 divided by 100 is equal to E1. So it is E1 value. And for this cell, okay, to calculate expected value, say this is the column total 85, this is the row total 35 divided by 100 sample total. That means 85 into 35 divided by 100. Say for E2, 85 into 35 into divided by 100. This is the E2. Like that E3, and this is the E4 value. So once we get expected value, then already we are having obtained value, so we can calculate chi-square. So chi-square of each cell, this the chi-square of this cell, chi-square of this cell, and this. So chi-square of each cell is calculated. Then these calculated chi-square values are added to get the total chi-square value. That means we are having O1, E1, so we have to calculate chi-square 1, here chi-square 2, chi-square 3, and chi-square 4. So chi-square degrees of freedom is equal to chi-square 1 plus chi-square 2 plus chi-square 3 plus chi-square 4. It's clear now? Say chi-square 1 is equal to O minus E. O observed value is 10. Say in this cell observed value is 10, and E expected value we got this 5.25 divided by E. Again that is E8 is 5.25. So chi-square 1 value we get 4.29, and the same, that is chi-square 2. So chi-square 2, that is for here observed value is 25. See, chi-square that is O minus E. O is 25 minus E, expected value is 29.75 divided by E, that is 29.75. So chi-square 2 value is 0.75, like that. Chi-square 3 2.31, chi-square 4 0.40. So to get total chi-square value, okay, it is chi-square 1, see chi-square 1 plus chi-square 2 plus chi-square 3, that is 4.2 plus 0.7 plus 2.3 plus 0.4. So these are added. So to get the total chi-square value, we got this total chi-square value, that is 7.77 something. So if you refer the chi-square table, so at 1 degree of freedom, why 1 degree of freedom? That is the degrees of freedom for 2 into 2 table is, as I told, like C minus, where it is, so degrees of freedom is C minus 1 and R minus 1, column minus 1 and row minus 1. So how many number of columns are there? Number of columns are, see, number of columns are 2, number of rows are also 2. That means 2 minus 1 into 2 minus 1. So 1 into 1. So degrees of freedom will be 1. At 1 degrees of freedom, so under this 0.05 probability, see, this is the chi-square table. At degrees of freedom 1, okay, C minus 1 and R minus 1. So at this 0.05 P level, so the our obtained value is 7.7. See, 7.7, so it is up to here, 0.01. So the obtained value is highly significant, more than this 0.01 P value. So it is said that the difference in mortality is significant, either at 2% level, or that is this percent level, or that is at this 0.01 P value. So that means anyhow, there is a role of drug to control the death rate in COVID-19. So I can say. So this is about a calculation of chi-square. So thank you very much. This is about calculation of T and chi-square test. If any doubts are there, you are free to ask. Hello. Hello.
Hello. No, sir.
Okay.
There are no queries in the chat box, sir.
Oh, queries are there?
No, sir. No queries.
Chat. No. Okay. If you are having any doubts, okay.
No, sir. No doubts. Thank you for
Anybody?
informative session, sir.
Oh, thank you. Welcome.
Now I welcome Mother sir for vote of thanks.
Namaste, Dr. Lakshmikant.
Sir, good morning. Namaste. After long back, we are visiting in this room.
Yes, I
Yes,
think
sir.
it's a good opportunity to interact.
Yes, sir. I really thankful, sir, because you had selected me as a resource person for this session.
You have done a fantastic job. We have felt you have really given justice for that.
Okay.
Actually, I was very happy that
Yes,
your
sir.
presentation style is very simple, very appealing. You are
Sir,
good
thank
teacher.
you very much. Thank you, sir.
And
Thank you very
teaching
much.
T-test and chi-square test, many people will confuse the audience. But I have
Sir.
attended your webinar. It is really clear presentation. I'm
Sir.
not overwhelming this because no questions are there. Okay, there is a proof.
Sir.
Our
Oh, okay.
Unpaired
It's
T-test is very minimum for all PG in Ayurveda. We have done
okay, sir.
very clear presentation with one example. Chi-square test is also useful whenever we do some further studies.
Yes, sir. Yes,
Becomes
sir.
effective. So you have helped us very well for understanding these two tests. Huh?
Thank you, sir. Yes, sir. Thank you.
And there are so many controversies in these things. I know many statisticians vary with this, but what you have done is really correct method of learning. So for
Sir,
that,
thank you.
on behalf of our administration, principal ma'am, and on behalf of all the PG departments of Taranath Government Ayurvedic College, and on behalf of delegates who participated, from the bottom of my heart, I acknowledge a vote of thanks for you. You
Yes,
have done
sir.
a job, and whenever in future we feel after the corona
Sure,
pandemic,
sir.
we can
Sure, sir.
arrange
Sure, sir.
workshop one to
Yes, sir.
one. You can physically
Yes.
come over to Taranath Institute.
Yes,
Thank
sir. Yes,
you.
yes. Thank you, sir. Thank you. Thank you, sir. Thank you very much. Thank you. Shall I leave, sir? Hello.
Sir, actually, there's
Hello,
one
sir.
query, sir.
Yes.
Oh, uh, the question is by Amrita. Could you
Hello.
explain the test of proportion in chi-square test with example?
Right now, what I had given example now. So, is there any proportion between this cause and effect, or drug, or this outcome? But we cannot. We are unable to know the strength of association. What I explained is it is only that is a like association and proportion. Hello,
Hello? Yes,
hello.
sir.
Huh.
Yes, sir. Continue.
So at this probability p value at this level, that is a proportion actually. Let's say like 0.05 level. So it is significant. We will say no. So that is a test of proportion actually. ಗೊತ್ತಾಗ್ಲಿಲ್ವಾ ಅಂತ ಸೌಂಡ್
Okay, sir. Thank you, sir.
ಓಕೆ ಎಸ್ ಎಸ್ ಹಾಂ
Okay. Okay. We will end the session now, sir.
ಓಕೆ ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್
Thank you, sir.